Okay, problem 6. We've got these spheres of radius big R. They're placed in contact as shown below. And, shown in the picture, which just looks like this. So, radius R, boom, radius R, and there you go. And we want to find the gravitational force they exert on each other. Well, we know that's F1, right? So, and then we want to find if we have two spheres that are 3 times as big, or 3 times the radius, so 3R, and there's another one, they're touching, 3R, what is going to be the gravitational force they exert on each other? So, whoops, sorry, come on, okay, there we go. Okay, so here is F1, that's what I defined it as, and then I'm going to call this force here, that this guy exerts on this one when they're at this separation, F3, and we're going to find F3 in terms of F1. So F1 is the gravitational force that this sphere exerts on this one. So F1 is going to equal G times the mass of one sphere, okay, which is capital, I'm going to define it as capital M. So capital M is the mass of each of these guys, okay? That's supposed to say mass, sorry. And so for the universal gravitation formula, remember this is gravitational force is big G M1 M2 over R squared. So here conveniently these are both the same mass, so we can just take M1 M2 and make that M squared. And then what's the distance between their centers? Well, it's R to get from here to the point of contact and another R there. So it's going to be 2R squared, quantity squared, okay? So that's going to be G M squared over 4R squared. That's going to be your F1, okay? So, fine. Then over here, we've got these guys. Now, first question is, what's the mass of these guys? Well, they're made of the same material, right? So the density of the spheres in the first one is equal to the density of the spheres in the other one, which I'm going to call 3. So I'm sort of calling this situation 3 because we've got 3 times the radius, and this is situation 1. Okay, so I'm using 3s for all the subscripts for this thing. Okay, so what that means is the mass of one of each sphere number 1 divided by the volume of each sphere in 1 is going to be equal to the mass of 3, a sphere in 3, divided by the volume of each one in number 3. Okay, so then we say M1 over, what is the volume of one of these, radius R spheres? Well, that's 4/3 pi big R cubed, right? Okay, so that's going to equal M3 over, now for the volume, 4/3 pi, and then the radius here is 3 times as much, so 3R cubed. Okay, now work through the algebra here, and you'll see that, let's see, I'll just go ahead and, come on, color change. Ooh, how about this lovely pink color? Okay, so you'll see the 4/3 and the pi's cancel, right? The R's cancel, okay, which means this is gone too. So really it's just this 3 cubed here. So what you're going to get is M3 equals 3 cubed times M1, which is 3 times 3 is 9, times another 3 is 27. So 27 M1. Okay, so now we can just plug in for our situation. Our situation 3, and we can say F3 equals big G, okay, times these M3s, which is 27 M1, right? So let's say 27 M1 squared, okay, divided by, and now the distance between the centers of these guys is 3R to get to here, and then another 3R over here. So that's 6R squared. Okay, so now this is going to be, sort of big, but what we're going to get is, so I'm going to take this 6 And I'm going to cancel that into, just to simplify this a little, let's see, what do I use? Oh, how about black? I know, writing in black, what a strange idea. So, stop it. Okay, so I'm going to divide 3 out of this to make this 2, and then divide 3 out of this to make this 9, just to make it a little more palatable, okay? So what I'll get then is F3 is going to be big G times 9 squared m squared, so 81 m squared over 2 squared is 4 r squared. And you'll notice over here F1 is G times big M squared over 4R squared. So F3 is 81 times F1. And that is your answer there. This is the kind of problem that you will really want to be able to do for the test. We love this volume crap. This volume and density stuff. We love giving you spheres and saying, oh, these are the same volume, but one has more density, so what is the difference in blah 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 blah, okay? And how the gravity works and all. So we love that stuff. Be good at that, is my advice to you.